Welcome to Math Challenge. Here we have a convoluted problem with a tame solution. Apparently it looks complicated, and in fact I myself had to struggle a bit with this problem. We have to find the green area, the green semicircle area which is inside a quadrant, a radius of the quadrant 5 centimeters. So we have to find the green area. It is apparently a bit off the beaten track, but actually it is very simple. Let us see how to do it and see how the complicated looking problem will have a very easy solution. So let M be the center of the semicircle. So from M we are drawing horizontal radius and vertical radius, the two white lines. The two white lines from M, the horizontal radius and the vertical radius, and since the radius would be perpendicular to the tangent, so we are getting a square. A square, each side of the square is equal to R, that is the radius of the semicircle. So when you join this OM, O is the center of the quadrant. When you join this OM, this will be the diagonal of the square, and the length of this diagonal OM will be R root 2. R is the radius of the semicircle. So a square with each side R, and OM is the diagonal of the square. So it would be R root 2. The length of this OM would be R root 2. So the dotted diagonal OM is R root 2. Now the white lines can be removed. In fact, we had to draw these white lines only to find the length of this OM. Now we know that OM is equal to R root 2. Now from the next slide, the white lines would be removed because we no longer need them. Now we join OP. O is the center of the quadrant and P is a point on the circumference of the quadrant. So when you join OP, OP is the radius of the quadrant, that is 5 centimeters. M is the center of the semicircle, so M to P will be the radius of the semicircle, which is R units, and OM we have already found R root 2. So O to P, the black dotted line, is the radius of the quadrant from the center of the quadrant to a point of the circumference. So OP is the radius of the quadrant, which is 5 centimeters. M to P, M is the center of the semicircle, so M to P is the radius of the green semicircle, that is R units, and OM we already have calculated R root 2. So in this triangle we know all the three sides. So in this triangle we know all the three sides. OM is R root 2, OP is 5 units, and MP is R units. So using the Pythagoras, OM square plus MP square is equal to OP square, that is R root 2 whole square plus R square will be equal to 5 square. OP is the hypotenuse, so R root 2 whole square plus R square will be equal to 5 square. And expanding we get 3R square is equal to 25. So R square equal to 25 by 3. That's the value of R square, 25 by 3. So the green area, which is a semicircle, would be given by 0.5 into pi r square. Full circle pi r square, semicircle half pi r square, or 0.5 into pi r square. 0.5 into pi into R square is 25 by 3. So 0.5 into pi into 25 by 3, and when you calculate you get approximately 13.09 square centimeters. So the required area, the green shaded area, the semicircle is 13.09 square centimeters. So that was Math Challenge. We will come back with more interesting questions, interesting problems. And be with us, subscribe to the channel, share and like the videos, and send us your questions and your problems, because all our services are entirely free of charge. Till we meet again, Thank you and goodbye.